Hello, everybody. Hello, my fellow dummies. I just admitted I'm the dummiest of all. You know, a couple of days ago, when I said I'm going to present at this event, and my wife asked me, what are you going to talk about? I said, machine for dummies. Will you come to my session? She said, no. I said, well, why? She said, oh, because I'm not a dummy. So here we are. Have you guys had fun so far today? Yeah. I mean, this is the last session, so that's the good news. The bad news is, I think I'm going to actually do live coding. So this is the only slides you're going to see. So actually, there will be no slides. I don't have much material prepared, so we just try to do as real as possible. And if there's online connection is working, then I can show you, I'll first show you how to do this machine learning coding on my laptop. If you want, you can follow along. And then if the network connection works well, then I can show you how to do that online without install anything on your laptop. And you have that perfect environment, you can do anything, play with it. So hopefully we can show you both and get started. I want to give you a little bit of background of myself. I was in, actually it's a little bit related to this company, Secud. I was in SAP world for a long time, and then this company recruited me. They're based off in Lucerne, Switzerland. It's a beautiful country. I have 2 photos here. They are real photos. I've been there, and if you've been there, you will love the city. That flower bridge in downtown is very famous. There are a lot of stories behind it. And they claim that somewhere near there is where democracy started. Some guys, because Switzerland is famous for that. Anyway, I'm an evangelist. I'm kind of a tour guide for that city, maybe, if you're gonna go there. So they many years ago they recruited me to join them in the first phase of the Secud. We built encryptions and the single sign-on for SAP, and the SAP bought that technology. A few years later, SAP bought that technology. Support the company, that side of business. So we all exited from the company afterward. Then afterward, I started my own company, and then a few years later, I sold my own company, kind of thinking I should leave the technology, maybe just doing some other things. So I started doing some venture investment, angel investment as well. But I kind of got bored after a few years. I was based out of Seattle. Oh, I'm sorry, that's dimmed out. So I kind of based out of Seattle doing that kind of work. Then, is that, okay, that's just, yeah. So then the company founder, they secretly working on the phase 2. I didn't know anything about it. I thought that company is all done. So they're actually doing some stuff with the data, which is kind of my passion. When I was with them, when they recruited me, left SAP, my passion was actually to build the security around the data, on the center of everything. And then they finally did that. And then when they talked about this, I was so excited, so I decided to join back with the company. So that's where I am, my background. That's the whole thing. So from now on, let's go back to the live coding. So if you want to follow along, that'll be perfect fine. If otherwise, there's 2 options, because this is the last session of the day. I know you guys are tired. If you want to take the opportunity to take a nap, that's also fine. Otherwise, so we can get started here. So the tool I'm going to using on my laptop, is this too small for you guys to see? Yes. Now we're gonna have something else to work on. Is there some setting on my laptop I have to do? So how do we make this bigger?
You go. There you go.
But that doesn't make the font bigger. So.
Yeah, just right click on the blue toolbar, go to the properties.
Ask them. They're the
Okay,
guys.
yeah. Oh, okay. So I can go to large. Oh, that's the cursor. Yeah, okay. The font. Yeah. Okay. So which font I should use? 36. Okay. Hey, here we go. Nice, thank you guys. So that's why I'm the dummiest of all. So the tool I'm going to use is called Jupyter. If you guys used that before, you all know about it. And the language I'm going to use is called Python. Both are open. I think both are open source. You can just, if you Google it, it will show you how to download and install them. So if you want to do machine learning on your own laptop, then these are pretty much the two things you need. Okay. So I already got that installed. I don't want to take the risk, install that live here. With Jupyter, you have this thing called notebook. And what it does is, it's very cool. It kind of bring up a browser, and then have all your coding inside the browser. So it's using a browser, HTML, as the language, actually, instead of like the text file, this is actually use HTML. So you can do markups, you can highlight certain things, make a bullet point. So it's kind of, you write a Word document. But inside this kind of Word document, you actually do the coding. There's blocks for comments, blocks for coding. It's very cool. Okay. So if you have it, this will be the first thing. There are many development environments there, and many of them are open source. I first actually tried something different. And then when I talked to another person, and they said I should try Google guy, he said they're using this tool inside Google all the time. So this is the development tool they actually use. So they said I should try Jupyter. So that's why I tried. Since then I fall in love with this tool. Okay, so what I'm gonna do is I'm gonna do this live, but I have something I'm gonna have to follow along because I'm getting old. I don't remember everything, so just have to have something so that it guides me. Okay, this is something I did before, and okay, so when we get started in the beginning, we start this notebook. You will see it will start my engine in the background, and bring up the browser in the front end, and then in this browser there is something called you can click here, say something new, and you can start a Python 3 project. Okay, so this is called a cell. Each of this block is a cell. Each cell is independent. Inside the cell, everything has to be consistent. But between cells, you can insert, you can add, you can delete. So it's a lot of freedom. However, overall, there's a coding flow. There's a logical flow from top to bottom. But the nice thing about it is, if you forgot something, you can go back and insert something. As long as it doesn't break your logic, the thing still works. Okay. This is it's much better than the traditional building environment. We have to write thousands of lines of code and compile it, and then realize something wrong, and then go back, fix. Here you can do 10 lines of code, and then another 10 lines of code each independently. Okay. So in Jupyter, In Python, actually, in the language of Python, there's something you have, the reason it's nice is because there are lots of libraries people has built for us. It's not because Python is the best language in the world. I think it's because there are a couple of things made it very popular as I learned over the time. Is first of all, it's this free style of coding is nice. It's interpreter based. If you computer science, you know what I mean. So you can insert, add, modify on the fly as you're running with your running code. Okay, and those are the three very popular after import. Those names are the three libraries that in machine learning that you're going to use all the time. The NumPy is arrays. It's all about the arrays. If you have mathematics background, you know what the array is. It's basically a square. Visually, it can be just a square of blocks of numbers and that kind of thing. It's called arrays. But anyway, it doesn't matter today. Then Pandas is another library built on top of NumPy. It's similar. The data structure there is similar to array, but it's a little bit enhanced. To me, it's more like a spreadsheet. We all know spreadsheet. Right? Everybody uses spreadsheet. Panda is kind of they have build this data structure, kind of make lots of spreadsheet features available to us. Okay. And then the last one is the plot library, so that we can visualize certain things. So those are the three libraries that's very popular with. And then what do you do? Once I put those code in, I can just click run. And that little button there means run. Then you can see a star here. It will try to load those library into runtime. Okay, into once there's a number, that means okay, this is successful loaded. If there's something wrong, for example, if you type the library's name wrong, say something like that, and then you will get an error. Okay, so that's how.
Plus.
Hmm?
You're going to have the browser bigger if you can.
Oh, okay.
Control plus. Control plus.
Drop plus. Oh, here.
On your keyboard and plus.
No.
Keyboard shortcut. So on the keyboard.
On the keyboard, the plus.
Control. Hold on the shift and then hit the plus key.
Okay.
There you go.
Is this big enough now?
Yes.
Okay. Well, I learned a lot of tricks today. Thank you guys. Truly thank you guys. That's the difference between old people and young people. Okay, you guys are really smart. I should call this machine learning for smarties. Okay, so we found the error, and then says what kind of error? We had no module named as this, so we have to go back, we fix that, and load it again. So now we have the 3. So anyway, as long as that has a number, it means that's successfully executed. Okay, so the first block we succeeded. And then if you usually when I do this, when I start this, I immediately put lots of cells in the browser just so that I can put lots of thoughts independently. And maybe I work multiple blocks of code simultaneously just as my thought goes. Okay, so how you do that? There's 2 key operations. You click the cell here so that highlights the whole cell. And then if you click A, you can insert a cell above it. So we can say, and if you have, when you do this, it usually default to an executable cell. So it has an execution button, a run button on the side. But I can change that. I can go here, say that this is not going to be a code block. It can be a markdown block. So with a markdown block, it's just like a coding. I can say, this is a live demo. Okay? And then there's no execution button there, so it's just comments, right? Okay, so so that's the insert. We push, when you highlight the cell, you push it, letter A, it insert the block above. And if you click letter B, it will insert a block below. Okay, so when I usually started, I just click a bunch of B's. So I have a lot of blocks I can work. Okay. So now we loaded those 3 libraries that you pretty much always use when you deal with machine learning coding. Okay, those are the 3. Those 3 libraries are not for machine learning itself. They're just the tools we're going to have to use to modify our data, dealing with to data preparation, as they call it. Okay. The next block I'm going to load. This is the example I'm going to use today. Is very famous. This is a machine learning library called sklearn. Okay, I think another name for it is called scikit-learn and all that. I think it's if you Google it, you will learn all about it. There's lots of libraries inside that package. Okay, they even different from our old traditional libraries where it's just blocks of code, little code. Functions we can call here. In this library, they also have a data set we can use. They have some data sets you can try. So we actually today, for the convenience to save the time here, we're going to just use one of the data sets inside the library. So I'm going to, from that sklearn, I'm going to import that data set, that whole data set. And then from that data set, I will load one of the specific data set. Okay, and this data set is dealing with digits. If you read maybe a little bit side story here, how I come up to learn about this. I never went to school for this. I mean, I graduated from University of Minnesota in computer sciences a long time ago, but it wasn't for machine learning at that time. So I learned this after I quit my investment stuff. I started to learn this stuff on myself because I see all the startups doing data science and machine learning. I was always amazed by them. You know, what they do is so fantastic. And then I just, later I said, I have to get hands-on this. Otherwise, I'm going to be a true dinosaur, you know. Maybe just like people collect bones of me. So I started to learn the stuff on Google learn from like the previous speaker saying from YouTube. There are lots of sessions about it. So that's how I learned. No, I didn't learn from any school or anything. Just this is all I learned. So I Google it and follow other people's example. So today this is how I just give what you guys how I learned about this. Okay, so this will create an object. This object will hold in this a data set. And what this data set about is actually some handwritten digits. And so we'll train we'll try to create a machine learning module to recognize those handwritten digits and then tell us what digits is. Okay, so that's all it is. So we're going to load this, and let's execute that, see if that works. So it's the first time you load it, it will take some time. So now you see this is number 4 because we execute this after this. Okay, so it's kind of sequentially marked them. You might be curious. Okay, what is inside this? What's inside of this digits? Well, one of it is a complicated data structure, and one of them is called data. And data block is actually the training data and all that, all the handwritten stuff digitalized. So it's not. I can show you one of them. So say the first data in the data sets. So that's what it is. So it's a block of numbers. It's a one-dimensional array. So you see that one bracket starts there, one bracket ends here. So it's a one-dimensional array of a bunch of digits. It doesn't mean anything to humans when we see this. It's just But the reason for that is in the way they do machine learning nowadays with those libraries, they require you to prepare all your data set, no matter how complicated they are. You have to prepare each individual thing you want to learn, that thing, into a one-dimensional array. Okay, so if it's a voice typically, I don't know, maybe a picture is better. Picture is typically two-dimensional, right? Then in the two dimensions, so first you of course, then you have at least 2 dimensions. Then on each pixel, you might have, if it's black and white, then you have a gray, and then you be another dimension. If it's a color, there'll be more dimension in that pixel. So this is how, so you have to, flatten all this out into a one-dimensional array, and then have the machine learn that. Now usually. We know, because I know this is handwritten digits, so it's kind of an image. So it actually, if we look in another way, I know you guys are smartest. So maybe you can already, if I present this data in a different way, then you should be able to recognize it. So I'm gonna change it. They have, this is Python. Okay, all this. Reshape and all this Python libraries, standard libraries. So if I do that, it changes into a 2-dimensional array. Okay, so now that has 2 brackets. You see that? 2 brackets. So each line is one array. So now this becomes a 2-dimensional array. Now, if you look carefully, you might be able to actually recognize what kind of handwritten digits this is. So if you imagine each number, the higher the number, the darker that block is. So if you imagine that, and the 0 means there's nothing there. So if you think that way, you probably can recognize this is almost look like a 0, right? Okay, so we can actually show you that. There's another, I don't remember the function name, so I have to look it up. Kind of remember it, but I just don't remember exactly. So now we're going to use that plotting tool. Okay. The reason I'm doing this is so make it intuitive, so that you understand why. Oops. I just type it. Okay. Is I am show, yeah, okay. So if I plot this out, and this PLT, if you remember, I imported that plotting library as a PLT. So I can call the function inside the PLT, and one of them is called the image show, because I know this 2-dimensional array is an image, and then I can using this image show tool to show it out. Okay, let's execute that, see what we got. So this is how that handwritten digits is. So we would expect that something looks like a 0, right? Okay, that's our data set. There's another thing maybe for your curiosity, because machine learning, you probably heard a lot of stuff about machine learning before. You want to know, they always say you need a lot of data to train your learning models, okay? So we probably want to see how many data we have in this data set. Okay, so that's wrong. I think it's just shape. There are different kind of functions inside for array. Some you have, it's a function, some is more like attributes of that data set. So when I put a bracket after it, that means I'm calling a function. If no, like this, that means this shape is actually an attribute of this data structure. So what this 2 number mean? That means this data set, this data structure here, is actually a 2-dimensional data structure. It has almost 18,000 rows, and each row is 64. There's 64 digits in that row. Yeah, as the previous example showed you, that 64 is 8 by 8, and if you make it a two-dimensional, so that's how that's what it is. Okay. So now we know what our data. Now we want to create a machine learning model and recognize those digits automatically and tell us what the digits are. Okay. So that brings the next major step is actually to load our machine learning engine. Okay. And which is this. I'm going to use this. This SVC module. The SVC stands for support vector. I forgot what's the last C for. Classify. Yeah, I think it's classify. Support vector classify. Yeah. So it's basically a classification module. Okay. It doesn't matter. There's you Google sklearn and SVC. It will tell us all about it. There's okay. And I'm gonna put this block over. This is all the data preparation part. So far, it's all about data preparation. What it is in all the standard machine learning libraries we have packages so far, they all follow the same standard name convention. They first they want you to create input data and a target. The input is usually a data set where you want your learning modules to learn. And the target is usually this is also what we call the supervised learning. So the target is actually what the answers are. Okay, it could be so. In the target is actually all the correct answers. Now, what is machine learning is about we give them a bunch of data and then we know the answers. In the supervised learning model, we know the correct answers. We want to feed those data to the model so that they do calculation inside, adjust its parameters inside, and eventually it will come up with answers that matches our target. And that's what the supervised learning is. Okay. So we're gonna have, and we all typically as a convention they call this X as the data set we want to learn from, and the Y is the target, is our supervised data, and the data we try to learn from, usually those in our case each data, if you remember, each row is a data is an object, and each object has 64. Attributes, right? And those attributes sometimes they call it features. Okay, that means it's how many features in your data set, and this is how you learn from features and come up with correct target answers. And then another thing you're gonna always do, probably typically will do, is using a library. And this is also a function library inside the sklearn. It's called the train and test split. Because this is the total data set I have. X is the total data set I have. And then I cannot use the whole data set for training. Then I don't have a way to test my learning models. So I usually want to split that. Here's the test size equals to 0.25. That means I want to split that in like 3/4 of them will be for training, and 1/4 of that will be for testing. Okay, so that's why the test size is 25%.
Can you slide over a little bit so you can get the rest of your line? Thank you.
Yeah, this is not a very important parameter. Okay, so what's important is pretty much here. Is a random start is in computer. If if you learn computer algorithm before, you know random inside the computer there is no actual random. Okay, random is also a statistical calculation. So usually if you feed the same random seed to a random generator, you pretty much always come with the same random numbers. To solve that problem, sometimes we have to feed a different random seeds. That's what that parameter is about. Okay. Yeah, there are lots of science behind machine learning, but the good news is with all this, you don't have to learn to know that. You can get started fairly quickly and then grow your learning from there. Okay, so kind of from here, we're pretty much done with data preparation. So the next step is actually training our learning models. Okay, so if I execute, this is called, pretty much this is kind of the standard in all these machine learning packages. They call the training step as a function named as fit. So as you can see, I split my input data x into two sets. One is called the training, x underscore train, and then y underscore train. So x underscore train is my training data set, and the y underscore train is my supervised answers. Okay, so that's why I feed this two here, so that this classify this is my model. This classifier will be trained on this data set with the supervised answer here. Okay, that's what. So let's execute that. I got an error. So it says classify is not defined. So I have to define that. Sorry about that.
Maybe go up. I think you missed.
Yeah, I missed the step. Yeah, I have to initialize it. Sorry about that. Well, this is very good because now we can go here. I can go anywhere above this line to insert that block. Okay, so now I initialize. This means I'm going to call this SVC package. I didn't put a lot of parameters with this function call. There are actually a lot of parameters with this. There's different kernels. Kernels is actually the mathematical model that it will use for this classifier. This classifier can use many different mathematical models. If you don't specify anything, it will use actually, I think the best is called the RBF, which is actually in mathematical visualizer is actually a smooth function. So there's others, there's a linear classifier, there's a polynomial, there's a bunch of different classifiers there. But this one is using Gauss function, something related to Gauss function. So it will model your data as close to reality as possible. So usually its performance is best. But as you can see, because it's a function, it's a smooth function. So the computation time is usually much longer than others. So it's always trade-offs. So now you see that's 13, this is 12, so obviously this is outdated. So I need to execute that again. So now this is actually correct. Our classifier is trained by doing this. So you see how quick that is? You know that when we split this data set by 75% goes to training. So that means this X train actually has 13,000 rows. Over 1,300 rows, I'm sorry. 1,300. So that's just 1 second, it's done. Okay, as your training model is done. So this classifier, now we can use that to actually recognize digits. And if you trust me, I'll show you that now, okay? That's the fun part. Yeah. So this is the one we're going to test against our test set. Remember, we split our input, the whole data set into two parts. One is for training, which you already used. Another is called a test we haven't used. We're going to reserve that now for this prediction, for testing. So we're going to put our test data. See, when we do the prediction using our test set, we don't put our answers with them anymore. We just give the test set. And hopefully it will come up with correct answers, right? So we put the correct answers in that variable called yPredict, okay? Okay, you're probably going to be curious what's inside of y. You can that's kind of the beauty of Python. You can just do this and say, show me what are the answers. Okay, so you see here are all the numbers, but we don't know if this is correct. Do you? I mean, I don't know. So another beautiful thing we can do is this. We can compare this, because this is the machine, the answer that machine gives to us. Remember, we also have another, our correct answers stored in y-test, right? Because I split the y into two parts as well. So we can compare this to, I shouldn't, if with one equal, that means I'm going to be cheating. I'm going to assign all the correct answers to predictions. But if I do two equals, that's actually a comparison. Okay, so it will do a comparison between the two. So now you can see, if it's true, this is kind of the powerful thing you can do in Python. You put this. Remember, each of this variable is not an individual number. Is an array. So I can just simply do an array comparison without, if we do I used to be a C program long time ago, C++. So for this, I have to do a for loop, while loop, and do each individual comparison and print it out. Here, you just do this, and it shows each individual comparison and give you the answers in an array. It's very nice, right? So if you glassing them over, you can see there's only a couple of cases that our prediction is not the same as a few cases. Like this is 1, 2, 3. So there seems to be, there's only 3 cases where the answers are different. So that's fantastic. There's another way. Maybe we want to know what are those 3 cases, right? Do you guys want to know that, just for curiosity? Yeah, so for that, I'm going to have to do this. I have to do this. I don't know other tricks for that, so this is what I did. So basically, I do a for loop and print out the 3 indexes of that array when the answers are different. Okay. So now we know that. What we can do, let's take a look of those, see why they are different. Maybe we can show an image why the machine fails in those cases. Okay. And for that purpose, I can bring up this thing we already did up here. So the first one was 66, right? So we put that in and show. So that show. So what is that number? Well, let's see why they are different. Let's see what the machine answer is and what's the. So that's our prediction. Sorry, it's an array, so it's not a function call. So it's a 7. So our prediction says that's 7. So what do you think the true answer is? Yeah, it's probably more like a 6. No, it's 2. Oh. Yeah, so that's probably a very bad handwriting. That's why. Okay, let's take a look at another example. I mean, this is where you can see the limitation of machine learning, or maybe the limitation of the data. Is the answer is, the answer is not obvious. There is no correct. Actually, probably we should say there is no correct answer to this. So that's 118. Okay, to me that's more like I don't know, maybe a 9 or 7. Okay, it says the prediction is 8. And that answer says 6. Oh, that's so strange. Maybe it's upside down. It's I don't know. That's strange to me.
Could you be indexing X test, not digits? When you're plotting from the entire set, not from the test set.
Oh, wow. Yeah, you are so smart. Yeah.
Once a day.
Yeah, I think I was so, because usually they don't, the model shouldn't be that dumb, and should be so huge difference. Yeah, exactly. Yeah, let's see that. Okay. So that's 6. Okay, so that's Y. Okay. Yeah, okay, so that's why. Okay, thank you. Yeah, it's my lesson learned. Yeah. Okay, so that totally makes sense. Otherwise, I'll be, how can be... So that looks like a 5 or 9. I don't know which one is that. I'm curious now. So even you guys don't want to see it, I want to see it. I insisted, so. Okay, so the correct answer is 5, and then our prediction says 9. So both has their reasons. Okay, so this is all about, this is machine learning. And you see not much lines of code, then you done this. But that's a good news. Actually, for the most part, if you use a standard library with a very well prepared data set, then machine learning is not that hard. Okay, that's pretty much what it is. The hard part is data preparation, because we're using a data set that's loaded as a part of the library. So all the hard work has been done. They already flattened it out in the beautiful array. So we don't have to do anything. In the normal cases, when we're dealing with real-world data, your data is typically coming from in a spreadsheet. And that's why in this case, I don't need to load Panda. But the reason I always have Panda there is because when data comes from spreadsheet, Panda is the best way to load that data. I can quickly show you another example. So you just so you have ideas of how to deal with the real world data. For example, this. So in this, I also use, as you can see, I also loaded sklearn for my learning, and I'm also all loading all this. It looks quite similar, right? Yeah, but this one is much a little bit more complicated, I would say. The data comes from in this line. As you can see, it comes from a spreadsheet. It's probably the separator is a semicolon. That means it's a text file with semicolon as a delimiter. Okay, so I load from that data. This is how this PD, as if you remember, PD stands for pandas at top here. So that's kind of the convention. So we load the data using this. We load that into a data structure. In this case, it's not an array. Panda is all about, they call it the data frame. Data frame is like a spreadsheet. It looks like an array, so I actually printed out that one, printed the head of that. You can see it's like an array, you know. But the difference is this: it has it always have the top, the first row as your headings, and then the first column is not part of your data. The first row is also not your data. So this is kind of the standard. This is your kind of row index. That's your column index. So that you can easily dealing with array. So if you're dealing with a mathematical array, if you want to address those columns, and it's kind of hard because you don't have an index for that. And so this addressing that shortcomings of array data structure. So data frame is much easier to deal with when you want to do data preparations. You pretty much always want to use in Python at least, using Panda package, using data frame. The real world data is this. So I'm gonna just quickly give you some. I'm not gonna go through this code with you guys. I'm gonna save time for maybe show you how to do this online without to install anything on your laptop in the Google platform. Okay. This here is this. Once you load the data, you see it. It's usually complicated. I've done government finance data last couple of months with some people, very smart people. And the spreadsheet is actually have over nearly 2,000 columns. So it's a lot of columns. So that means a lot of features. But if for anything we want to analyze or predict, usually, you know, we only need a few columns from those data. Sometimes 10, sometimes 20, but we definitely don't need all that thousands of columns. And if actually the more irrelevant columns you have, the worse your prediction gonna be, because those are gonna be, you know, gonna contradict some of the things and make too much noises in your data. So so how that's what the data scientists come in. As a data scientist, if you're not a machine learning guy, you usually have to prepare your data so that, figure out which data is relevant, which data is not, and that's a very hard part. You have to do lots of statistical analysis. Are we running out of time? Oh, sorry about it. Just one quick, maybe I'm so enthusiastic about it. So if you want to do this on Google, this is all you have to do. It's called Colab, okay? Colab, if you do Colab and search on Colab, C-O-L-L-A, make that bigger. I'm gonna use your trick. So this, if you do that, oops, sorry. So now I'll do this explain. This part cannot be bigger. So if you do that, it actually gets you to the Google environment. It's a Jupyter online Jupyter environment where you can do the same thing, exact thing, without install anything on your laptop. Okay, and it's totally free.